Hello, this is Dr. Arberg, and I'd like to welcome you back to our course, Introduction to Reinforcement Learning, Motion Control. The topic of our lecture is reinforcement learning, agents, critics, and actors. What does an AI machine learning expert do in an autonomous motion control product development? Well, first he has to obviously understand the specifications as stated by customer need or a marketing spec document. He has to select the training tool for the system, such as Python, TensorFlow, MATLAB, AWS, Azure, IBM, Google, etc. He has to also select an agent. There are several agent options like DDPG, TD3, Critic, etc. And also select the hyperparameters, which will state when to stop the, for example, the training. He has to embed the dynamic simulation and the animation that he received from the system analyst, and also state the initial conditions where the simulation will start the process of the iteration. He has to program the reward function, and the reward function, as we saw earlier, has to be based on a system specification, what we like the system to do, and this comes in with input from all team members. Then he has to run the training process. It may take hours or days. It took weeks for Google to train the system to compete with the world champion of Go game. And then he has to validate the results with the team and update by trying another agent as needed. And finally, when the training is done, he has to deploy the neural network into the real system, working with the team's computer scientists. Now, the reinforcement agent tasks include they have to receive observation and reward from the system and environment. We saw it earlier. Here's the system and the environment, and he has to receive the observation and the reward after each iteration. Then he needs to select an action by multiplying the observation variables by the control neural network parameter. Here's the controller neural network. Here's the observation. They multiply him just like in a PID, and out comes the action. And this is actually done every iteration. Every iteration, he has to update the neural network parameters using the changes in the observation and reward. We'll take a closer look at it later. And then he has to continue to iterate and learn to make decisions while increasing the total reward of the process. Finally, he has to stop the learning process when the total reward converges to its maximum value based on a hyperparameters setup. There are several agents to choose from. The list is over here by MATLAB. These are, for example, the list that they're given, the Q learning, deep Q learning, DQN, policy grading, the deep deterministic policy grading, so-called DDPG, twin delayed deep deterministic policy gradient, one that I showed earlier in demo, active critic reinforcement, and so on and so forth. The active critic operation is shown over here. Here's the reference with this small chart. It uses slightly different names than what we use in motion control. For example, the policy is actually what we call the neural network controller. And over here, the environment with the system, we call it system and environment. And then we have over here the value function, which is the optimization. And we'll take a look in one of our upcoming lectures, how is optimization being done. But basically what we saw earlier, the actor actually getting the state into the neural network, into the policy, and get out an action. The action acts on the actuator to move the autonomous system based on the results that change in the system state. Then the actor receives the reward. And also that state goes into the critic. Now we'll see the critic and the actor exec functions in the next slide. But what we have over here is the optimization process, and it's like called here temporal difference. And again, we'll look a little bit in it in one of the next lessons. And that temporal the temporal arrow, what it does, will change the policy parameters, or what we call the neural network controller parameters, such that it will become better in giving the system and the actor a better reward for the next iteration. Now, the actor and critic in reinforcement learning motion control is analogous to PID tuning. Over there, we saw only 3 parameters in example, and over here, we may have hundreds of parameters. So the actor task, again, is to apply the observation on a neural network controller, then use the neural network controller output to command the actuator, then change the environment with a new observation, and then receive a reward for this action after each iteration and update the total expected future reward. So actually the actor is getting a new reward every time it iterates. Now the critic task is to calculate the maximum expected future reward using its own updating neural network. So the critic actually estimates the total reward from first iteration. And as we see over here, the prediction in green is what the critic is estimate the total reward for the whole process from start to end. And it is pretty high. Now, when the actor is getting the reward every time he tries, he may get a very low reward, and this will update the total estimated reward for the entire process, the future reward. And then there is a difference, large difference between what the critic estimates and what the actor actually updates every iteration. But then eventually, when the two converge, this actually brings the iteration and the learning process to an end. And at that time, the neural network controller is ready to be deployed to the real system. So training is completed when the critic estimate of the total reward over here, the green, converges to the actual total future reward calculation. And this is in blue. And the red over here is the average of the estimate. Now, let's ask ourselves a question. How do we bring in an AI machine learning specialist to a reinforcement learning product development project? So the options very similar to what we saw for system analysts. First of all, we may hire him. If the company is large enough, that's fine. They typically go for $250,000 a year. They're being employed by all the giants, by Google, by IBM, by Amazon. And what this course actually tries to motivate the students is to actually try and consider becoming one, becoming an AI machine learning specialist. And that is, if you're a computer scientist, you may consider the following options. exactly as a system analyst. You may obtain higher degree, Master of Science or PhD. You may self-study online courses and related textbooks. You may self-study related system analysis with tutorial, MATLAB, AWS, Azure, IBM, and Google. Or you can start hands-on, test a deep racer and try to model it, build the simple mechatronics with the real force and motion control. You don't have to be a mechanical engineer really to build a simple mechatronics. Usually the tutorials take you step by step in doing it. And then possibly apply for an engineering job in a company that develops autonomous systems, like SAR, for example, Boston Dynamics, Tesla, SpaceX, they're all doing it. And then once you get join a reinforcement learning product development projects and computer science and work closely with the AI machine learning specialists. And if you feel confident enough and you have a good idea and you understand the market needs, then you may actually try a startup company with a very simple differentiating reinforcement learning feature. With that, I'd like to thank you for listening, and I look forward to talk to you in our next lesson. Thank you.